Hello guys, in today's video we will continue from the last question paper. So we've been naming organic compounds. So let's start. We have CH3, CH, CH3, CH, CH2, CH3, and then CH, CH3, CH, CH3, CH2, CH3. So if you remember very well, I asked you from my last video to name the structure. I hope you did it, but I didn't get any feedback from anyone. So let's name this structure before we continue. So in this structure, remember from the rules we spoke about on the last video, we said you should find the longest carbon chain first. So let's start counting from this one. So we have 1, 2, 3, 4, 5, 6, 7, right? Which means we are dealing with a heptane. So now the second rule is to look at the substituents. We have a methyl. The longest carbon chain is a heptane. So now we look at the substituents. We have a methyl, which is this one. We have this one as well, and this one, and then we have an ethyl. So now let's talk about the positioning of the groups. Remember we said we start counting from the one closest to the substituent, from the carbon closest to the substituent, right? So in this case, this is the one closest to the substituent. So we start numbering them. 1, 2, 3, 4, 5, 6, 7, right? So when we name this compound, on position number 2 we have a methyl, position number 4 we have another methyl, position number 5 we have another methyl. So because we have to name this structure in, we name the substituents in an alphabetical order. So which means we'll start with ethyl. Ethyl on position number 3. So when we write the name of this, we'll come and say 3 ethyl, and then we put the hyphen. And then on position number 2 we have a methyl. Position number 4 we have another methyl, and then position number 5 we also have another methyl. So we have 3 methyls, which means it's a trimethyl. Trimethyl heptane. That's the parent name. So now let's move on to our next question. Let me erase this. So on this question, we will be expected to draw the structure. It's 2.2.3 trimethyl pentane. So let's start. So this means we have 3 methyl groups, methyl substituents on our structure. And the parent name is a pentane, which means it has 5 carbon atoms. And this one tells about the positioning of these methyl groups. So now let's start by drawing the pentane. I think it's better to use the line structure for simplicity. So okay, we can do this 1, 2, 3, 4, 5 carbons, right? Let me erase these numbers. so that we don't get disturbed. Let's continue. So on position number 2, this is 1, 2. On position number 2, we have a methyl and another methyl. All right, let me draw this nicely. Sorry about that. So on position number 2, we have 2 methyl groups, right? And then on position number 3, we have another methyl. So this is our structure. Now let's move into the next one. We erase this one, and then we do the next one. We have isobutyl cycloheptane. So cyclo means we're dealing with a cyclic structure. Heptane, we have seven carbon atoms. So let's draw this first. We have 3. That looks more like it. So we have 1, 2, 3, 4, 5, 6, 7 carbon atoms, right? And then we have isobutyl. So if you can look at my second video on how to name alkyl substituents, then you will know which one it is. So here we have 1, 2, 3, 4 carbon atoms, and then we'll bring together these two, because this one has no other substituent, so it doesn't really matter where you put the alkyl substituent. So you can either choose to put it on position 1, position 2, position 3, 4, 5. It doesn't really matter. So let's put it in any position. So I chose this position. So we have 2, 1, 2, 3, 4 carbon atoms. So this is our isobutyl cycloheptane. So let's move to the other one. So the other one is 2.3 dimethyl 6 phenyl heptane. So we're still dealing with 7 carbon alkane, since it's a heptane, and then we also have a phenyl group, and then we also have 2 methyl substituents. So we have 2 types of substituents, methyl and phenyl. So let's start with the parent name. The parent name is a heptane, which means we have 7 carbon atoms. It was 2, 4, 6, 7, right? So on position number 2, we have dimethyl. Position number 2, we have a dimethyl. On position number 6, so it's 1, 2, 3, 4, 5, 6. Position number 6, we have a phenyl. Phenyl is an aromatic 6 carbon ring. So there it is, we have our structure. Now let's move to the other one. The other one is, which is 5 isopropyl 3, 3, 4 trimethyl octane. So this is our parent name. So the parent name tells us we are dealing with 8 carbon atoms on our carbon structure or alkane. So the substituents we have 3 methyl groups and also 1 isopropyl at position number 5, and the methyl groups are on position number 3, and 4. So let's draw the structure, guys. So we start by drawing the octane. So it's 2, 4, 6, 8. Let me draw it nicely. I like structure. I'm a bit of an artist, so I like structures. So we have 2, 4, 6, 8, right? So on position number 5, let's start count. Position number 3, we have methyl, right? So this is the position. We have 3, we have 2 methyl groups on position number 3. They are our methyl groups. And then on position number 4, we have another methyl group. Position number 5, we have an isopropyl. Let's try to shift this. Position number 5, we have an isopropyl. There we have it. So that's our structure, guys. Isopropyl 5, 1, 2, 3, 4, 5, 6, 7, 8. So on position number 3, we have 2 methyl groups. Position number 4, we have another one. Therefore, our name is a trimethyl, which means we have 3 methyl groups. And then octane, because we have 8 carbon atoms. So thank you guys for tuning in. Please do